Okay, nangu Newton's second law, question 4 from this November 2016 question paper. So in the description box, as usual, uzothola ama-links for other questions engiwaphendulile. So question 4. Yes, okay, two blocks of mass 8 kilogram and 4 kilogram respectively are joined with an inelastic string of negligible mass. So now 8 kilogram, now 4 kilogram connected by a string. The string runs over a frictionless pulley. The 8 kilogram block is on a horizontal surface while the 4 kilogram block is on an inclined plane of 40 degrees with the horizontal. Boom. Yes. Okay. Now the coefficient of kinetic friction for both blocks is 0.2. So this is the coefficient of friction, so it's common for both surfaces. Lago 8 kilogram, the surface between the 8 kilogram block, okay, the coefficient of friction between the 8 kg and the horizontal surface is 0.2. For the 4 kilogram block and the inclined plane is 0.2. But the 4 kilogram block accelerates down the slope, right? So system yethu, the 8 kilogram block imuvela phansi, and then the 8 kilogram block imuvela to the right. Since the system is moving down in terms of the 4 kilogram block. Now, go 4.1, but this is stated Newton's second law of motion. This is the law. Basically, a force actor on an object, it will accelerate in the direction of Leo, or it will accelerate in the direction of the net force, and then the acceleration is directly proportional to the force and inversely proportional to the mass. So 4.2, draw a free body diagram of all the forces acting on the 4 kilogram block. So the 4, the max I4 asitshela ukuthi siyoba nama-forces ayingaki, I4, right? Sinama-forces I4. Now, for the fact that this 0.2 as a coefficient of kinetic friction, it means ama-surfaces wethu, the incline, the horizontal surface, anani, offer both objects amalokanje i-friction. So therefore, siyoba na 4 yama-forces kule 4 kilogram block, including a, well, kula ma-forces ayi-4 kune-frictional force. Ube careful ke la. Kumele sibe careful. So since it's a free body diagram, siba ne-dot in the middle. The first force kuyoba yilokanje, kuzoba yi-tension. Kuzoba yi-tension. And then the second one kuzoba yi-weight. And then sibe ne-normal force. The normal force is included. You must include the normal force kulokanje kuma free body diagrams wakho. And then so say so fast now 1 2 3, and then siba ne-frictional force as the fourth force, right? As a force here to S4. So this is the kinetic friction, and it's opposing the direction of motion. Since the 4 kg block accelerates down the slope, so since imuvela phansi, the acceleration is going to point in the opposite direction, which is up the slope. So now free body diagram here to 4.3. Calculate the frictional force between the surface and the 4 kilogram block. All right, again. So, okay, so as with the frictional force is calculated as Fk equal to mu k times the normal force. The mu k this mu k is tshela ukuthi the mu k represents a coefficient of kinetic friction, and then the normal force kumele siyicalculate since mu k is 9, right? The normal force is equal to the perpendicular component of the weight. This is the weight, the perpendicular component is this force, this one, right, is equal to the normal force, and the perpendicular component The perpendicular component is equal to weight times cos 40 degrees, and then the parallel component is what? The parallel component is weight times sine 40 degrees. So in this case, if frictional force here it is over equal to 0.2 times the perpendicular component, which is weight times sine 40 degrees. Now we further do this by substituting a weight. The weight here it's mass times mass times gram. So what's the mass of the block? It's 4 times the gravitational acceleration g times sine 40 degree. Now I answer here to get 0.2 times 4 times 9.8 times sine 40 degrees. This is equal to 5.0 5.04. Now I answer it again. 5.04 ngenzeni ke manje la? Go back. Wait. Okay. There's a blunder la. Ngitheni? It's what? The normal force is equal to this perpendicular component. Mina instead ngisebenzisa okay. There's a blunder la. Let's do this again. In fact, lana I need to erase cos 40 degrees, not sine. Lana cos 40 degrees. I apologize for this. So lana is equal to 0.2. Weight is 4 times 9.8 times ngiyaphinda futhi. Eish. Ngathi ngabiza someone angiklaphe ngempama. Ngenza ama-mistake amaningi manje. Okay, anyway. 0.2 times 4 times 9.8 times cos 40 degrees. This is equal to 6, wait. Okay, I see round off to 2, but it's about 6.01. Round off to 2, yes. I wasn't sure. 1 Newton. This is the frictional force. 4.4. Calculate the magnitude of the acceleration of the system. So since it's khuluma acceleration la, we have to use ubani Newton's second law. So ngizo erase lana so that we can have a clean slate where singayenza ama calculations wethu now. Let me erase. Okay, 4.4 azange ngisuselo kanje i-free body diagram for the 4 kilogram block. Why? Sizoyisebenzisa in setting up ama equations for the system of ama simultaneous equations. By the way, second law, if ever uzo calculate a tension or acceleration, you need a system of equations, ama simultaneous equations. You need a set of 2 equations. Since this is a 2-body diagram, it means that there's 2 unknowns. The first unknown is tension. The second unknown is acceleration. So 2 unknowns, you need a set of 2 equations. You need 2 equations to calculate the acceleration about the calculator, right? Since the tension is also unknown. So the 4 kg block is also the first equation. Let's do this. I think we sell a component la. We also have our components la. Now my components wait. The components are important since now they play a role in setting up our equations wait. Kanjani na? It's because of this. Now the first equation, so you're telling a 4 kg block. Now again, the first equation yakho for Newton's second law was set by looking at iloganje. direction of motion. Like the 4 kg block is a mover in this direction, is a mover down the slope. So therefore, uzosebenzisa all the forces parallel to the surface, or parallel to the inclined surface. Bheka, it's because of the 4 kg block mover down the incline. So i-equation yakho uzoyiseta ngale ndlela le, uzothi F net equal to the mass times acceleration. Since the 4 kg block is moving down the incline, so uthatha wonke lama forces are parallel to the incline azokunikeza the net force. Ngichaza ukuthini ke? Let's choose up as positive. Let's choose up as positive. Bheka ke manje, tension uyoba positive, right? It's the force eyibheke phezulu. And then plus Fk is also positive, ubheke njani phezulu. Another force a parallel to this inclined plane ubani, F parallel. So yena since ubheke phansi, it's going to be minus F parallel. This is equal to ma. This is equal to mass times acceleration, right? So the normal force, the F perpendicular, the weight, you don't consider them, since the object here to move down the incline. If the object was moving up, okay, then we'll consider N no F perpendicular. F N no F perpendicular. But since the object here to move down the incline, so it means so seven lama forces are parallel to that incline. Now we substitute again, man. So the mass, what's the mass? It's 4. Acceleration unknown. Tension is also unknown. F frictional force here to Fk weight with 6,01. So you calculated it previously. And then line it's minus F parallel. F parallel is as a substitute. So about 4 times 9,8. Okay, close bracket. Let me erase that. So about sine 40 degrees equal to mass, it's 4a. Then it's equal to 4a. Then we further simplify lana. Okay, we have 4 times 9.8 times 4 times 9.8 times sine 40 degrees is equal to 25.20. So we have plus 6,01 minus 25,20. 20 is equal to 4a. Therefore, this and this are like terms. We give about 6.01 minus 25.20 equal to, it's minus 19.19. T minus 19.19. 19 equal to 4a. This is our equation 1. Now for equation 2, for equation 2 siyomthola ngokusebenzisa block 8 kilogram. Alright, now for 8 kilogram, let's see. Alright, now in order to set up the second equation, so dinga the free body diagram for 8 kilogram, right? So this is the free body diagram. Now free body diagram yakhona, it's normal, tension, and then there's what again? There's weight, there's also what? There's also friction, bunny, with Fk as well, right? With Fk. Now, bheka manje. Bheka manje. Check this out. So this is the free body diagram for bani with 8 kilogram. Now, Lana ku 8 kilogram, the second equation so iseta using FK nobani no tension, since these are the forces that are parallel to the horizontal surface, or like the 8 kilogram block is over horizontally along this horizontal plane. So check F net, so calculator using the forces that are parallel to the horizontal plane, which is Fk nobani no tension. So for the second equation sizothi ke F net so mthola using the 8 kilogram block for the 8 kg block. This is what's happening. F net is equal to MA. Since, okay, in this whole system, 8 kilogram and 4 kilogram by accelerator. So now accelerator meaning lana it's second, it's apply second law, na last be apply one second law. So give about 8A F net is what if we choose to the left as positive. Give about FK positive minus the tension, right? Now since the frictional force ku 8 kilogram angnayo, I have to calculate it, girl. And we know that FK is calculated as FK times the normal force minus bani, light minus tension. So Fk is mu k times normal force, and the normal force on a horizontal plane is always equal to the to the weight, and then mu k is 0.2. The normal force is what is equal to the weight, and the weight is calculated as 8 times 9.8 minus t equal to 8a. Siyaqhubeka ngapha 0.2 times 9.8 times 8, this is equal to 15.68 15.68 minus t is equal to 8a, and then this is our second equation. Yes, this is our second equation. Now I can either use a substitution method, or I can use ilogaj, or I can use the elimination method, which is the method this way apply, right? So this is equation 1. Equation 1 uti tension minus 19.19 is equal to, okay, I'm running out of space now. T minus 19.19 is equal to 4a. Equation number 2 it's 15 comma, or I think it's swati ngibhale so ngithathe lo t ngim-align nalo t waku equation 1. So kuyoba minus t plus 15.68 is equal to 8a, right? So bheka ke ngiyo-add equation 1 no equation 2 bese ngithola what ke nangi-add equation 1 no equation 2 ngiyosebenzisa i-elimination method in this case, right? So why am I adding lama equations? Ngifuna ukuthi t no t ba-cancelana. So nangi-add equation 1 no equation 2, the t and this t they cancel, t cancels t, and then minus 19 plus 15.68 minus 19.19 plus 15.68 is equal to bani, is equal to 3.51 minus 3.51 minus 3.51 is equal to 4 plus 8, that's 12a. Right, so then we divide both sides, 12 sitholani na minus 3.51 divided by 12, this is equal to negative 0. Le cancelana na lena, so a is equal to negative 0.29 meters per second. So therefore acceleration is equal to 0.29 meters per second downward. Le negative lena isitshela ukuthi we are acting downward, since we chose up as positive, to the left as positive, right? So therefore the answer yethu iphuma as a negative because of the chose ilokai sign as positive in the opposite direction. So, and the 4 kg block is it accelerates down the slope. Now 4.5, how will the acceleration compare if the positions of the 8 kilogram block and the 4 kilogram block are switched? Choose from greater than, less than, or the same, and explain your answer. All right, 4.5 I think ngibhale la 4.5 mina ngithi izoba greater than. Remember bathini basibuza ngani nge-acceleration. What will happen to the acceleration if siswitcha u8 simbeka ngapha, u4 simbeka ngapha, right? So if the bigger block iba on the incline, the acceleration is over greater ngoba izo-slider much more quicker compared to the 4 kilogram block. So izoba greater than, right? Provide a reason. It's because of this parallel component izoba greater than, izo increase, right? Thus making the system ukuthi accelerate kakhulu, angisho ukuthi accelerate kakhulu. So izinto ezi2 zoba affected la. It's the parallel component yenzani ya increase, and then what else increases? It's the net force. The net force F net increases as well. The F net increases as well, since the parallel force and the parallel component ya increase, and the F net ya increase. Why ngithi F parallel ya increase? It's because of the weight increases. 8 kilogram. Okay. This is the 4 kilogram block, right? Nyla down the incline, on the incline. So the 4 kilogram block is the driving force for the whole system. So nangithatha u8 ngimsusa la ngimbeke ngapha, u4 ngimbeke ngapha. Now the system, right, yoba ne higher acceleration. Instead ukuthi kube no4 la sekuba nobani no 8 kilogram. Thus the weight does what? Increases. Yenza ukuthi system accelerate much more quicker. So that's why ngithi the F parallel yenzani ya increase now because of there's a bigger mass manje. Then the F net, the net force for the whole system is will increase now because of F net is equal to bani MA, and if acceleration you increase, the F net does what? Increases now. And then but tension is will remain the same. So 4.5 uphelela lana. The last question for our question 4. Thanks for watching. Nangabe you enjoyed this video, please leave a like. Don't cry. Share a comment nangabe une question in the comment section. Ungakhohlwa ukusubscribe, ungakhohlwa ukushare nabangani bakho as well. Yeah, so in the description box there are other videos ongawabukela for this question paper. Thanks for watching. Asibonane on the next one. Bye bye.